I will discuss some question of linear transformation which had come different type of comparative exam. In my earlier video I had discussed this type of question also. Today I will discuss also more question. First question, let L Rn be the space of linear map from Rn to Rn. That means this is the linear operator from Rn to Rn. And kernel T denote the kernel of T. Then which of the following statement are true? Option 1, there exists T belongs to LR5 such that range T equal to cut T. Option 2, there does not exist T belongs to LR5 omitted with 0 such that range T equal to cut T. Option 3, there exists T belongs to LR6 omitted with singleton set 0 such that range T equal to cut T. Option 4, there does not exist T belongs to LR6 omitted with 0 such that range T equal to kernel T. Are you getting the option? Well, first option. For first option, since range T equal to cut T, I will apply the rank nullity theorem. We all of us know by rank nullity theorem, rank T plus nullity T equal to dimension of V. Since here given rank T equal to nullity T, nullity T means cut T, so obviously 2 rank T equal to, here the dimension of V is 5, that means rank T equal to 5 over 2. Rank T be fraction number, this is cannot possible. So option 1 is a wrong option. Are you getting? Well, that means obviously option 2 is a right option. And option 3, there exists L belongs to LR set the dimension is 6. And here it has indicate rank T equal to nullity T. By this expression, that imply rank T equal to 3 since dimension of V is here 6. Obviously this is possible. How this mapping will be? Consider a linear transformation T from R6 to R6 such that T of x1, x2, x3, x4, x5, x6 equal to 0, 0, 0, x1, x2, x3. Okay. Then cut T equal to, obviously this linear transformation equal to 0. That means this is equal to 0, 0, 0, 0, 0. That means cut T contain set of those x1, x2, x3, x4, x5, x6 such that x1 equal to x2 equal to x3 equal to 0. This is contain the cut T. And what is the image T? Image T is set of those x1, x2, x3, x4, x5, x6 such that x1, x2, x3 should be equal to 0. That means obviously range T and kernel T is equal. Are you getting this mapping? This is actually the left shift operator. For this mapping, range T and kernel T always similar. So obviously option 3 is a right option. There exists T belongs to LR6 such that range T and kernel T is equal, and option 4 is a wrong option. Are you getting? That means option 2 and option 3 are right. Discuss one more question of CSR net which had come June 2015. The question is, let V be the vector space of all twice differentiable function on R satisfying f double dash minus 2f dash plus f equal to 0. Now define a linear transformation T from vector space to R2 by defined mapping is such that T of f equal to f prime 0, comma f0. Now my question, option 1 indicate T is 1, 1 and on 2. Option 2 indicate T is 1, 1 but not on 2. Option 3 indicate T is on 2 but not on 1. And option 4 indicate T is neither on 1 nor on 2. This is very basic question. The equation f double prime minus 2f prime plus f equal to 0. This is actually look like the differential equation y double prime plus ay prime plus by equal to 0, which has an auxiliary equation m square plus am plus b equal to 0. We all of us know, this is I have taught in second year, this type of differential equation always has double root. In the question, given the function f double prime minus 2f dash plus f equal to 0, this is same as the auxiliary equation m square minus 2m plus 1 equal to 0. That imply m minus 1 whole square equal to 0. That imply here the root are 1 and 1. And we all of us know, an auxiliary equation has a double root and the root are same, then this equation would be such type c1 e to the power lambda x plus c2 x e to the power lambda x. So, since here the root are 1, 1, that means ft equal to c1 e to the power t plus c2 t e to the power t. Are you getting? From this equation we can tell this is. An auxiliary equation has a double root and the root are same, then this equation would be such type c1 e to the power lambda x plus c2 x e to the power lambda x. So, since here the root are 1, 1, that means ft equal to c1 e to the power t plus c2 t e to the power t. Are you getting? From this equation we can tell this is. Now we have to find, is the solution be basis? In differential equation, we all of us know, when Wronskian of this root are not equal to 0, then these root are linearly independent. And we all of us know basis mean that span every vector of the vector space and also linearly independent. So, notice Wronskian of e to the power t comma t to the power t equal to, just put the value, then this would be e to the power 2t. That means, since this is not equal to 0, that means the solution e to the power t comma t to the power t is a linearly independent solution. And obviously this e to the power t and e to the t to the power t span the solution f double prime minus 2f prime plus f equal to 0. So obviously this solution is a basis of the vector space. And since this is basis, and here the linear transformation T is defined as T of f equal to f prime 0 comma f0, then T of e to the power t equal to e to the power 0 comma e to the power 0, which is equal to obviously 1 comma 1. And in R2 we all of us know the standard basis are 1001. So we can write this as a combination of standard basis. Also t e to the power t means here the mapping f prime 0 comma f0. So this would be e to the power 0 times 0 e to the power 0 comma 0 e to the power 0, which is equal to 1 0. And also we can write 1 0 as a such type as a standard basis. And with respect to this standard basis, the matrix representation is 1 1 as a first column and 1 0 as a second column. And since this determinant of TV is not equal to 0, that implies the linear transformation is bisecting. That means 1 1 and 1 2 both. Getting when a linear transformation be 1 1 and 1 2? Must know from every linear transformation I will get one matrix representation, and when a matrix representation be non-singular, then obviously this linear transformation be bisecting. Are you getting? Now I will see one example which had come N.B.H.M PhD exam 2021 exam. The question is, let n be positive integer and b be the real vector space of polynomials with real coefficient and degree at most n, and consider t be a linear operator on the vector space V defined by t of fx equal to x f prime x minus f of x minus 1. Here f prime x be the derivative of fx, then what is the trace of t? To find the trace of t, that means we have to find the matrix representation of this linear transformation. Since here the vector space of real polynomial with real coefficient, that means consider the basis vector are 1 x square x cube up to x to the power n. Then here notice t be a linear operator from vector space to vector space. T be a linear operator from vector space to vector space. Here V be the real vector space of polynomial with real coefficient and degree at most n. So consider the basis vector as a standard basis vector 1 x square x cube x to the power n. Since here the arbitrary fx, so at first consider fx equal to 1. When fx equal to 1, then t1 would be x times 0 minus 1, which is equal to minus 1. Now consider fx equal to x, and for this find t of fx. This would be x times f dash x means 1 minus x minus 1. That means this value is equal to minus 1. Okay. Now I will consider fx equal to x square, and I will find the image for the basis vector x square. Then t of x square would be x square times f dash x means 2x minus f of x minus 1 means here, since x square, that means this would be x minus 1 whole square. That means this term would be x square plus 2x minus 1. Okay. This is the image of t of x square. Consider fx equal to x cube. For this, consider the image of t of x cube. Then this would be x times 3x whole square minus x minus 1 whole cube, which is equal to actually 2x cube plus 3x square minus 3x plus 1. If we consider similar to fx equal to x to the power 4, then let's see the image of t of x to the power 4. This would be x times 4x cube minus x minus 1 to the power 4. This is equal to 4x to the power 4 minus Now apply binomial expression here. Then this would be x to the power 4 minus 4x cube plus 6x square minus 4x plus 1. Then after calculating, this value would be 3x to the power 4 plus 4x cube minus 6x square plus 4x minus 1. This is the image of t of x to the power 4. When I will say fx equal to x to the power 4, this value would be continue. Then the matrix representation of t, obviously order of the matrix representation would be n plus 1, because the basis vector is 1x squared up to x to the power n. That means this order would be n plus 1. So order of the matrix representation would be n cross 1 times n cross 1. Here would be t1 tx squared tx cube tx to the power 4 so on, and here would be the basis vector 1 x squared x cube x to the power 4 so on. Okay, since t of 1 equal to minus 1, that means the matrix representation would be minus 1 0 0 0 so on, and t of x equal to also minus 1, then this would be minus 1 0 0 0 0 so on, and t of x square would be x square plus 2x minus 1. So this would be x square plus 2x minus 1. That means this would be minus 1 2 1 and other part would be 0, and t of x cube is, this is equal to 2x cube plus 3x square minus 3x plus 1, means this would be 1 minus 3 plus 3 plus 2 and other part would be 0. Since t of x to the power 4 equal to 3x to the power 4 plus 4x cube minus 6x square plus 4x minus 1, then for tx to the power 4 the value would be minus 1 4 minus 6 4 3 so on, and notice the matrix would be, notice the matrix, and since trace means sum of the diagonal of the matrix, then minus 1 plus 0 plus 1 plus 2 plus 3 so on, and this would be continue 1 plus 2 plus 3 plus 4 plus 5. This would be continue n minus 1 times, and obviously trace means this sum, and notice for this 1 plus 2 plus 3 up to n minus 1 means at first evaluate this sum. This would be n into n minus 1 over 2, and for this is minus 1. That means this is the actual value of tracing. I hope my all viewers have understood how we have to find the matrix representation of any arbitrary function. Okay, just think, this is very important. This type of example are actually very important for not only N.B.H.M, for all type of exam. Okay, today I will stop here. In my next video I will discuss different type of question which had come in various type of competitive exam. But at first I will highly recommend you, please see today's video with pay attention, and don't forget to subscribe my channel.